Okay, so we have done a left tail and a right tail test so far with um, population standard deviation. So on our table F, to get our critical value, we went all the way down to the bottom to get that critical value. Just like in confidence intervals, when we have a sample standard deviation, that's when we have to bring in degrees of freedom. So still the same concept, nothing different. So, at least that's good. All right. So we're going to go over this example, which is another right tail, and then we're going to see a two-tail test as well. Probably maybe in a second video. Depends how long this one gets. All right. So pretending that we were in class, then we had some breaks and weekends and stuff. So just to set some reminders about when we did confidence intervals, that was last week now. What were the keywords to indicate whether we used a z-score or a t-score? Meaning that value you had to look up in table F. And the keywords are not just sample and not just standard deviation, but together, a sample standard deviation or a standard deviation from a sample. And so when we had a z-score, we found the value to use at the bottom of table F. And when we had to use a t-score, we found the values by using degrees of freedom, which is abbreviated DF, which again is n-1. Same thing for hypothesis testing. And this is what normally is. Well, what normally is. It's very rare that you're going to have a sample average, but a population standard deviation. All right, so let's knock this baby out. Here it says the average movie ticket in 2010 was $7.89. A random sample of 15 movie tickets from the suburbs indicated that the mean cost was $11.09, pretty high, with a sample standard deviation of $4.68. At 0.05, can it be concluded that the mean is higher than the national average? So again, it gives us all the information, just a matter of picking out what we need. So again, our first step is to state our hypothesis statements. So our first one is our null, and then our alternative, our claim. So here it's saying that the average movie ticket is $7.89. Just says it right there. So it's saying that the average is $7.89. And then how to know where to look for the question mark. Okay, here's the question mark. And then read that over again. It says, can it be concluded that the mean is higher than the national average? So higher is another way to say greater than. Remember, these are always the same numbers, okay? All right, so now when we find the critical value, because it gave us a sample standard deviation, we're going to need degrees of freedom. And so degrees of freedom is n-1. And out of this sample, there was 15 movie tickets in the sample. So for n is 15, our degrees of freedom equals 14, right? So 15 minus 1 gets us 14. So we're going to look at one tail at alpha at 0.05. So we need to go down in the degrees of freedom column, and then rather than going all the way to the bottom of the table. So here it says degrees of freedom is 14. And then one tail at 0.05, there, yeah, okay. So 14 at one tail at 0.05. we get this 1.761. It is a right side, so it's going to be on the right and it's going to be positive. Okay, so our critical value is going to be this number in the table, and this sets up our critical region. When we do our test value, again, anything greater than 1.761 will be in the rejection region. Okay? Anything less than that won't. Finding the test value is the exact same. They just switch up the symbols a little bit, but again, we're going to take our new minus old mean divided by standard deviation over the square root of n. So our new mean from our sample was $11.09 minus our old, which should be up here. And then down here, the sample standard deviation is $4.68 divided by the square root of n. Now, just be careful. It's tempting to accidentally put this value in, but it's still the n value of 15. And do the top. We'll get 3.2 or $3.20. And we do the bottom. Odds are this ain't going to be pretty. It's not. So 1.2084. Okay, so you can take this and divide by that, but again, in your calculator, you know what the top is. This is already the bottom value, so you can do 3.2 and then hit divide. And then if you hit second and then ANS for answer, that'll put up this whole thing in there without having to round it. If you're using a TI-80, or excuse me, a TI-30, like the smaller calculators, I think it's still in the same buttons. You're going to have a second up here in the corner, and then at your negative symbol, you have ANS there, so it'll still work the same way. So we can press second, this puts all that in there. So 1.208, blah, 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 blah. And we get 2.65. Okay. So this is where you decide. Is 2.65 more positive, more to the right than 1.761? Hope you said yes, because it is. 2.65. All right, so that means it fell in the critical region. So say that test value is in critical region. So if it's in the critical region, we reject the null hypothesis. And then the results, or summarize that. So if we reject the null, it means we're like, adios. He's saying that there is enough evidence to support the claim. And again, what is the claim? The claim is that the average is higher than the national average. So this suburb, or from the suburbs of a large U.S. city, that their average is significantly higher than the national average. Okay. And yeah, $11 is pretty, I don't know, kind of expensive. Okay. So I'm gonna stop this video and start a new one just in case if this is going too long. So the next one, we will do one that is a two-tailed test. So getting a little interesting.